We continue Unit 10, Graphing Square Root Functions, with Flap 2 in our foldable. Graph the following square root equations. State the domain and the range. Y equals the square root of x plus 3 minus 6. We know that the original graph starts at 0, 0. My transformation is left 3 and down 6. Write down the coordinates of the square root parent function. 0, 0, 1, 1, 4, 2, 9, 3. Remember from last semester, we take the stretch in the graph and multiply it to the y values. This will give me the movement from my new starting point. So 0 times 1 is 0, 1 times 1, 1, 2 times 1, 2, 3 times 1, 3. So my new center is left 3, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. My new points now, I'm going to use my old x and my new y, and I'm using these as directions. This tells me I'm moving my x out 0 and my y out 0 from my new point. So this point stays the same. I move to the right 1 unit and up 1 unit. Right 1, up 1. Next point. Right 4, starting again from this new point here. 1, 2, 3, 4, up 2. Starting from my new point, new beginning point, my new starting point, out 9, up 3. So my graph is now going in this direction. My original graph was this one. This graph now starts at -3 down 6. And if this graph would have continued moving, it would have been in the it will be in the positive coordinate. So this is positive, positive. So I look at my x values for my domain. My x values are going from -3 to positive infinity. Therefore, x is greater than or equal to -3. My range, my y values, are going from -6 to positive infinity. So my range values are going, our y is greater than or equal to -6. In example 2, I have y equals negative the square root of x plus 1. Again, let's write down the values of the original parent square root parent function. The y equals the square root of x. Remember, we are multiplying our y values by the number in front of our problem. So I'm multiplying all of these by -1. This gives me my new movement at 0, 1 times -1, -1, 2 times -1, -2, 3 times -1, -3. My original parent function again starts here. But how is it moving? Well, this is a graph that is reflecting because of the negative sign, and it is moving left 1 unit. So I will move left 1, and it did not move up or down, so my new point is here. This is a graph that is reflecting, so my new points will be 0, moving right 0, up 0. So I stay here. The next point on my graph is out 1 to the right, down 1. My next point will be to the right 4, down 2. So starting at my new point right here. 1, 2, 3, 4, down 2. My last point to plot is 9, -3. Starting at my new beginning point, out 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, down 3. So curves in this direction. We start at our new beginning point, -1, 0. This is a graph that if it continues going to infinity, my x values will be getting larger, so they're positive, but my y values will be getting smaller because it is going down. So I am looking at my x values. X. I am going from -1 to positive infinity. So my graph is going to be x is greater than or equal to -1. These numbers are getting bigger on the x-axis the farther out I get. My range. My range is y to y. The range is going from 0 to negative numbers. So my range is less than or equal to 0. It starts at 0, but as the graph goes down, the y values are getting smaller. Example 3. Y equals 1/2 times the square root of x minus 2. My graph is shrinking by 1/2, moving right 2 units. So we will multiply all the y values in the parent function by a 1/2 shrink. This will give me 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1. 3 times 1/2 is 1.5. So my new plot will be out 2 units to the right, up 0. And these are my new moving places. My first new movement is out 0, up 0. So starting at my new point, out 0, up 0. Next one, out 1, up 1/2. Next set, out 4, up 1. And the last one, out 9, up 1.5. So this is a graph that has moved over and shrunk. The domain. The new starting point is 2, 0. It will end in positive infinity. My x values are positive, my y values are positive. My x values are going from x to positive infinity, or going from 2 to positive infinity. So x is greater than or equal to 2. My range. The range. The range is going from 0 to positive infinity. So those values are getting bigger. So the range is y is greater than or equal to 0. Last graph. Example 4. I have a reflection and a stretch. Right 4. And up 2. Again, we want to write the original points for the parent function. My original parent function started on this point. What is my new point? To get that, I multiply by the number in front. So 0 times negative 2 is 0. 1 times negative 2, negative 2. 2 times negative 2, negative 4. 3 times negative 2, negative 6. My new point is going to be located 4 to the right and up 2. So this is the point that I will do my new movement on. Out 0, up 0. So this point stays the same. Next movement, out 1, down negative 2. Remember, we start at this point. Out 1, down negative 2. Next movement, out 4, down negative 4. Starting from here. Next movement, out 9, down negative 6. Again, starting from here. Well, I'm off the graph, so I'm going to stop there. Domain. Domain are my x values. This graph starts at 4, 2. It ends somewhere down here in infinity, and this infinity is out positive units, down negative units. The x values are from 4 to positive infinity. So my x is going to be greater than or equal to 4. Y values. Y values will be moving from 2 to negative infinity. So the y values will be getting smaller. So the y will be less than or equal to 2. This concludes Flap 2 of the Unit 10 foldable.